All right, here we are starting back with number 6. I'm not really sure where this question came from, but if you want to just make a table maybe, plug in some different diameter values and volume is the output and see how they relate. But ultimately, it makes kind of like an exponential, like that. We'll talk more about that in class, or you can come ask me. This one is 7 here. Negative powers, means you flip the fraction. And that's just the way I like to say it. I'm sure there's a more mathy way out there, and you could put some examples as well. Number 8. Okay, so 1/2, 3/4, -1/3. Okay, you're going to multiply fractions, multiply the exponents in that situation. So that gives you 1/2 to the -9/4. Okay, now use your rational exponent rule to put the fourth on the outside. Well, actually, you know what? It's negative, so let's deal with the negative first. So the negative flips on the inside then. It makes it 2 to the 9/4, and then we'll take it to the 4th root of 2 to the 9th. And I'm just going to type in what is 2 to the 9th. It's 512. So the 4th root of 512. And now I'm kind of curious if that is something else. I'm going to type in the 4th root of 512. Nope, I'll just leave it like that. Great. Okay, number 9. Okay, yep. So number 9, compounding annually, so it's going to be like an exponential. So starting initial of 1,000. He's gaining, so it's going to be 1.1, like that. And it says 15 years later, so I'm just going to go plug that in the calculator, type it in just like it looks here. 1,000, oops, times 1.1 to the 15. That comes out to 4177.4. Cool. Let's go on 10 here. Oh yeah, right. Number 10. I'm just telling you about. I'm giving you a heads up on that. Can't really prep you for that one. 11. Okay, cool. So I'm gonna go type this equation into Desmos. Okay, f of 3, f of -2, f of 0, f of 4. I'm just going to go type it in Desmos just like it looks. So, and you do need to include f of x. Okay, f of x equals x minus 8. Oops. X minus 8 to the 2. Great. Now, you can actually just type in f of 3. Now, or you can go plug a 3 in for x and see what you get. So that's 25. F of -2, 100. F of 0, 64. And f of 4, 16. Now, for the other part, it's basically what is the output? Sorry, what is the input? So that it's kind of like saying like that. What's the input such that the output is 20? Right? Now that doesn't work obviously, but what you can do is just write that one down. And there's probably a way to solve it with Desmos, but I'm not going to do that right now. It's going to take too long. So x minus 8 squared. So that's what we're trying to find. Just again, let f of x equal 20. Then you'll find the input to get that as an output. We'll take the square root of both sides. So that'll be plus or minus square root of 20 equals x minus 8. Add 8 to both sides. So x equals plus or minus square root of 20 plus 8. And that's your answer. That is the most correct unrounded answer. That's 2 answers, by the way. There's plus or minus there. And that makes sense because it's saying there's a parabola. What input gives this output? Well, there's 2 of those. So that's why it makes sense that you'd have 2 answers. Let's get number 12 here. Domain and range. Okay, so the first domain, this is for like the first graph there, they're open circles. So it's going to go from -5 is less than x is less than -2. No or equals to in there. Or you could also use this notation. -5, comma, -2. Make sure you use parentheses because it's open circle. Range going from -4 less than y up to 4. Or in this notation would be that. Now again, you don't have to have both of these, it's just either this notation or that notation. I like this notation better. Just make sure you use brackets when it's closed circle. So let's see the second one. Domain starts at -4, and then it just goes forever in the positive direction. So x is greater than, sorry, look at that, greater than or equal to, no, not or equal to, it's open circle. X is greater than -4. That's all you have to say. You could add this in there, but you don't have to. So that's the domain. And the range starts at -1, and it goes up forever. So y is greater than -1. Cool. And let's go on. 13. I mean, you're just sketching. It's a hyperbolic function with a vertical asymptote here. Which kind of looks like that. You know, just do it in the calculator and make a table. You know, have Desmos make a table for you. Pretty simple. 114. Okay, 14 is totally something you can do by graphing. Just a second. Get the lights back on so it's a little brighter in here. There we go. Totally something you can do by graphing. Or what I think they want you to do is, so for the y-intercept, that's when x is, sorry about that. Okay. Okay, and then x-intercept, vice versa, is when y is 0, which gives you 4x equals 12, because it just gets rid of that. So x equals 3, so your x-intercept is 3, 0. And I would definitely recommend graphing it to find those. Let's see, 15. Okay, yeah, well, this is a quadratic. So some quadratic probably has 2, could have 1 or 0 x-intercepts. So you could graph it. You might get some nasty answers. This one, though, is factorable, so I'm going to factor it. But whatever method you use is up to you. So this is the same as, you can factor out, this would be x plus 5 and x minus 2. 5 times -2 is -10. 5 plus -2 is 3. So therefore, the x-intercepts are -5 and +2. Notice how they're opposites of these. And let's do 16 on here as well. Okay, so 11,000 is the initial value. It's depreciating by 11%, so it's not 0.11. That would be wrong. It's going to be 11,000 times 0.89. That's depreciating by 11%. So plug a 5 in there for that first part. So I'm just going to go type that in the calculator. 11,000 is 0.89 to the 5. That would be 5 years. It's worth 6142.46. Okay, that's part A. Okay, now part B. This is a kind of tricky here. If it's 3 years later, we could plug in -3 actually to go back 3 years. Or if you want to look at the table or the graph, they'll do the same exact thing. I'm just showing you a quicker way. 15603. Because it'll still be depreciating by that same multiplier, that same ratio. So that's what would have been worth back then. And I'll start back on 17 in a second.